Hey everyone, welcome to The Explainer. Today, we are shining a light on a massive environmental issue that is quite literally hiding in plain sight. When we think about planetary crises, we usually picture these huge, dramatic changes that are super easy to spot. But there is a silent shift happening all across the globe. It's altering the very lungs of our planet. And here's the crazy part, it doesn't actually erase them from the map. It poses a really fascinating, if slightly alarming question. What exactly happens when a forest is dying, but the trees are still standing? We've been so conditioned to believe that forest loss only looks like a completely clear-cut landscape, right? Just a bunch of stumps where a thriving woodland used to be. But the truth is, some of the absolute worst ecological damage is completely invisible from a distance. So today, we're going to solve this mystery together. Okay, let's dive right into this. We really need to draw a hard line between two terms that get confused all the time: deforestation and forest degradation. Deforestation is permanent. It's the total conversion of forests to other land uses. Think of, clearing a whole forest to build a shopping mall or a massive cattle ranch. The forest is just gone. Forest degradation, on the other hand, is a decrease in quality. The forest area is still there, the trees are still standing, but its biological wealth, its health, and its overall vitality are severely diminished. So let's take a second to formally define what this hidden threat actually is. According to international experts from the UN's Food and Agriculture Organization and the ITTO, forest degradation is basically the reduction of a forest's capacity to provide goods and services. So a degraded forest might still have a canopy overhead, sure, but it has lost its vital ecosystem structure. It might be producing way less wood, filtering less water, or maybe it's only holding on to a tiny fraction of the biodiversity it used to support. The forest is still there, but its capacity to function is completely compromised. Just take a look at the Amazon canopy here. It isn't completely gone, but it is deeply, deeply fragmented. And this fragmentation breaks up habitats. It exposes the dark, humid interior of the forest to harsh winds, blazing sunlight, and isolation. Scientists call these edge effects, and they slowly alter the microclimate. It makes it literally impossible for certain native plants and animals to survive, even though, technically speaking, the land is still classified as a forest. All right, moving on to what is actually driving all this damage. When we look at global forest loss, the sheer scale of the issue might actually surprise you. Commodity-driven deforestation, that total clearing of land we talked about, only accounts for about 27% of a loss. Think about that. That means a staggering 73% of forest loss is actually driven by degradation factors. We're talking forestry and logging, shifting agriculture, and wildfires. They make up the absolute lion's share of the impact on our global forests. This invisible crisis is by far the majority of the problem. And what's really interesting is that the causes of this degradation shift completely depending on exactly where you are in the world. It's not a one-size-fits-all issue. In Latin America and Asia, the dominant driver is logging for timber, paper, and pulp. That accounts for over 70% of their degradation. But jump over to Africa, and more than half of the degradation is driven by collecting fuelwood and charcoal, simply because so many communities still rely on wood as their primary energy source. Meanwhile, up in Europe and North America, it's mostly a mix of harvesting forestry products from planted trees and, increasingly, massive wildfires. Now, you might be wondering, well, what if we only log a few trees and leave the rest? That can't be that bad, right? It's a fair question, but the reality is that even selective logging totally disrupts the vegetation structure and those crucial microhabitats we mentioned earlier. Hauling heavy machinery into a forest just to extract a few highly valuable trees compacts the soil, reduces moisture, and significantly drops the biodiversity of the entire area. Even the absolute most careful extraction leaves a lasting scar. Okay, so we know the drivers, but what does this actually mean for our planet? Let's explore the severe ecological consequences that ripple out from this. Seeing exposed, heavily eroded soil on a hillside like this is a perfect visual of degradation's physical toll. You see, forests protect inherently fragile soils. When you remove even just a portion of the trees, you lose those massive complex root systems that quite literally hold the earth together, and that leads to severe soil erosion, dangerous landslides, and the loss of fertile topsoil, making it incredibly difficult for the land to ever bounce back naturally. And unfortunately, the loss of soil is really just the beginning. Degradation acts as this terrifying negative feedback loop. First, you have carbon emissions. Intact forests are amazing carbon sinks, but degraded forests actually release their stored CO2, turning them into net emitters. Then there's biodiversity loss. We're losing an estimated 137 species of plants, animals, and insects every single day due to overall forest destruction, driving what scientists call the sixth mass extinction. And finally, hydrological disruption. Fewer trees mean less moisture in the air, which fundamentally changes rainfall patterns and drastically increases the risk of drought. Which brings us to this absolutely staggering number, 38%. Current research shows that an alarming 38% of all remaining Amazon forests are currently degraded. That's primarily due to a brutal combination of fire, logging, edge effects, and extreme drought. Nearly 4/10 of one of the world's most vital ecosystems is currently operating at a severely diminished capacity. And the true gravity of this whole situation really boils down to this fact. Carbon emissions from this degradation total up to 0.2 petagrams of carbon every single year. To put that in perspective, that is equivalent to, if not actually greater than, the emissions from total Amazon deforestation. So the big takeaway here is that this invisible, creeping degradation is exactly as dangerous for our global climate stabilizers as the total, highly visible clear-cutting we're used to seeing. All right, I know that's heavy, but it is not all doom and gloom. Let's pivot and talk about solutions. Now that we understand the scope of the crisis, let's look at how we fight back. There are some incredibly resilient, super effective methods being used right now to heal these landscapes. One of the coolest approaches is assisted natural regeneration, or ANR. It's a highly cost-effective strategy that basically just relies on nature's inherent ability to bounce back when we give it a little bit of breathing room. The steps are beautifully simple. First, you protect the degraded land from grazing livestock and human pressures. Second, you just rely on the mature, healthy seed trees that are already nearby. And third, you step back and allow natural succession to reestablish the ecosystem. It's really just about helping nature do what it already knows how to do. Another awesome method is farmer-managed natural regeneration, or FMNR. Instead of spending tons of money planting new seedlings, farmers actively manage the trees and shrubs that naturally sprout from dormant roots already in the soil. They select the healthiest native stems, they protect and prune them right alongside their crops, and they remove unwanted branches so they aren't competing for water. It's brilliant because it allows communities to produce wood, restore soil health, and boost climate resilience without the crazy high cost of traditional replanting. And when you look at folks doing this hard work on the ground, whether it's breaking hard soil with a pickaxe or managing or recovering terraced hillside, it becomes crystal clear that ecological restoration is ultimately a human effort. But here is the absolutely crucial takeaway. None of this works without empowering local communities. Giving local farmers and indigenous peoples proper land rights and real authority over their natural resources is the absolute prerequisite for these restoration techniques to actually take root and succeed. A perfect example of this is happening right now in the Tigray region of Ethiopia. By using community-managed exclosures, which are basically just areas strictly protected from grazing and clearing, they've successfully restored huge portions of degraded semi-arid land. And this isn't just an environmental win, it is a massive human win. This restoration directly improved local food security and livelihoods. It proves that reversing land degradation works best and honestly lasts the longest when it directly benefits the people actually living on the land. So it really all boils down to this. Biodiversity restoration and climate mitigation are mutually reinforcing goals. Healing our degraded forests doesn't just solve one isolated problem. It solves multiple planetary crises all at once. When we restore a forest's capacity to thrive, we sequester carbon, we save countless species from extinction, we stabilize our global water cycles, and we secure the livelihoods of literally billions of people. So, we'll leave you with this. The invisible crisis of forest degradation might be hidden up in the canopy, but it directly impacts the very air we breathe and the water we drink. The big question for all of us now is, how can we help support the sustainable, community-led forest economies that are actively working to reverse it? It's a huge challenge, but it starts with awareness, shifting our consumption, and supporting the local communities right on the front lines. Thanks so much for joining me on this explainer, and keep asking the big questions.